This video is going to go through an example of how to calculate the Doppler-shifted frequency. What is the frequency heard by an observer who hears a 770 Hz siren on an ambulance traveling 30 meters per second towards her? Assume the velocity of sound in air is 345 meters per second. First, let's write down everything we are given. We know the frequency of the siren is 770 Hz. We also know the velocity of the ambulance is 30 meters per second. We will call this v sub s, or the velocity of the source. The last piece of information we are given is the speed of sound in air, which we will call v, and this is 345 meters per second. In this problem, we are trying to find the Doppler-shifted frequency, or the frequency of the siren that the observer hears, which we will call f prime. The basic equation for Doppler-shifted frequency is f prime is equal to f multiplied by v divided by v minus v sub s. The reason we take v minus v sub s in this equation is because the sound is moving towards the source, so we would expect the Doppler-shifted frequency to be higher than the actual frequency. If the sound were traveling away from the observer, then we would have added in the denominator. Next, we will substitute all of the values we are given. F prime is equal to 770 Hz times 345 meters per second divided by 345 meters per second minus 30 meters per second. Make sure you either use parentheses around the subtraction and the denominator or subtract first. Otherwise, your calculator might not give you the answer you expect. If we enter this correctly, we should end up with a Doppler-shifted frequency, or observed frequency, of 843 Hz. This concludes our Doppler-shifted frequency example.